Welcome to AI Podcast. Today we're digging into a new EMNLP paper called SCRIBE from FAIR's Fawzi and Tanya Käser's group at EPFL. It's about getting small language models to give useful, trustworthy feedback to students.
Small models, as in the kind a school could actually run on modest hardware, right?
Exactly. The core idea is simple to say and surprisingly effective in practice. Teach a small model to think in steps, call the right tools along the way, and then double-check itself before it speaks.
When you say tools, what does that look like in a classroom setting?
Think of a Swiss Army knife for a course. There's a syllabus and textbook search, so the model can ground answers in the actual material. There's a topic map tool that knows which weeks and concepts depend on which. There's a grade calculator. And there are behavior-focused tools that summarize a student's activity, explain feature names, and even estimate how changing study habits might affect performance.
So if a student asks, "How do I pass this course?" the model might first check the topic map to see prerequisites, then peek at behavior signals, then compute how many points they still need to pass.
That's the idea. And SCRIBE doesn't just call a tool once. It runs in a closed loop. Picture a careful chef tasting as they cook. Call a tool, look at the output, reflect, correct course if needed, and only then serve the answer.
Got it. How did they train that behavior into a small model?
They used a two-stage recipe. First, they collected real student questions about feedback reports from several MOOCs. Then they asked a stronger model to generate step-by-step reasoning traces with tool calls, and they filtered those with a judge to keep only clear, actionable, and correct examples. With that synthetic data set, around 7,000 examples, they fine-tuned small open-source models using low-rank adapters in two stages. Stage 1 teaches how to start the reasoning and pick the first tool. Stage 2 teaches multi-hop tool use and how to craft the final answer.
And the self-reflection you mentioned happens at inference time, not just during training?
Right. At runtime, the model decides whether to call another tool, whether it made a mistake, or whether it's ready to answer. That loop is what helps it recover from errors.
I'm curious about results. Did the small model actually hold up against the big ones?
On automated evaluation with a human-aligned judge, the SCRIBE-tuned 8 billion parameter model beat its untuned base on relevance, actionability, and tool choice, both on courses it saw and on a held-out course. And in a user study with 108 university students, its responses were rated on par with a much larger Llama model and GPT-4 for things like usefulness and clarity.
That's pretty striking. Any sense of why students liked it?
Some participants called out the conciseness. The small model tended to get to the point while still giving concrete next steps.
Speaking of next steps, does SCRIBE generalize beyond the tools it was trained with?
They tried that. They introduced a new web search tool at evaluation time. The SCRIBE model started using it in zero-shot fashion when it made sense, which suggests it learned the general pattern of reason, decide, call a tool, reflect, not just memorized a fixed script.
Nice. Now I can hear skeptical listeners asking about the fine print. What are the caveats?
A few. First, correctness is still tough. Gains there were modest, partly because the baselines were already pretty strong. Second, tool relevance can slip if the initial plan is off, so better planning and calibration would help. Third, the domain is specialized. The tools are tailored to specific MOOCs. Porting this to a different school or subject means building the right tool set again.
And what about evaluation bias? If a big model generates training traces and another big model judges the outputs, could they share blind spots?
That's a fair concern. The authors try to mitigate it by aligning the judge to a human rubric and by running a human study. Still, more educator-led evaluations and, ideally, measures of actual learning outcomes would strengthen the case.
Did they release anything practitioners can use?
Yes, code, data, and trained models are open-sourced, so a teaching team could adapt the pipeline, plug in their syllabus or grade rules, and fine-tune a small model that runs locally, which helps with privacy and cost.
Let me play back the big picture to see if I've got it. SCRIBE shows that with structured training data, two-stage fine-tuning, and a self-reflective loop, a small model can carry a sensible conversation with a student, call course-aware tools when needed, and deliver advice that students find as helpful as answers from much larger systems.
That's the headline. And the practical takeaway is this. If you want classroom-ready AI, don't just chase bigger models. Design the right tools, teach the model how and when to use them, and build in a habit of checking its own work.
Right. And for future work, push on planning, test in more subjects and languages, and measure learning gains, not just perceived quality.
Exactly, that's SCRIBE. Thoughtful scaffolding, not brute force.
Thanks for walking us through it. This has been AI Podcast. If you try the release in your own course, we'd love to hear how it goes.
Same here. Until next time.